The end. So today the essential question is, how did our atmosphere form and evolve? Your topic is atmosphere. Notes go on page 8. The assignment we're going to do is going to be on page 7, and your code is 3, 2, 1. There's a little delay there, and that messed me up. So I was like, wait a minute, I'm holding up 2 fingers, but it says 3. No. So, first thing you're going to get down on your notes is the definition of the word atmosphere. And we are not the only planet with an atmosphere. Other planets have atmospheres. So there are, it's not just like Earth is alone on this. But it is a layer of gas that surrounds and protects the planet. The ways that the atmosphere kind of protects us. That's one of the things I want you to get down in your notes, even though it's not written up here. There are a couple things our atmosphere does to protect us from what is around us. Can you think of some ways, some things our atmosphere does to protect us? Josh? You're on to something. Can you explain it a little bit more, I don't know what the word is, thoroughly? Can you explain it for us? You're on to something. We'll see if somebody else can finish it off for you. Ben, you doing okay?
Yeah.
Okay. Nick?
Our ozone layers blocks dangerous rays.
Yeah, so there's one thing that you want to get down, that it protects us from UV rays, right? Ultraviolet rays are rays that are emitted from the sun. They're the things that make you tan, but too much exposure to those things causes mutations in your skin cells, and you wind up with skin cancer and skin damage and stuff like that. You ever see that movie, There's Something About Mary? Or, no, it's with Ben Stiller, but there's this lady who tans all the time in it. And if you tan too often, it breaks down your skin, and you have damaged skin pretty rapidly. The more you're exposed to the sun, the more your skin gets damaged because of those UV rays. Our atmosphere, how many we've had, so we're going to start with the first one, because we had an atmosphere before we've got this atmosphere. And our first atmosphere was made up of mostly 2 gases. So however you want to get this down, I would not write that whole blurb. I would shorten that, because that's a lot of writing. Hey, Brian. So you want to get down that it was composed of hydrogen gas, which is the first element on the periodic table, and it was composed of helium gas, which is the second element on the periodic table. What's that? If there's one thing you know about those 2 gases, though, it's this. What do those 2 gases do when they're on Earth? Like if you put them in a balloon. Yeah, gravity doesn't pull them down hard enough, right? So they don't fall towards Earth because they're so light they don't have enough gravity for Earth to pull them down. So as a result of that, these gases, like it says, were too light to get trapped here. And as soon as the sun had a solar flare, which is like when a huge geyser of plasma kind of erupts from the sun and releases a whole bunch of energy, that energy hit the Earth, we predict, and blew away, stripped away our atmosphere. So we had nothing left. Our second atmosphere was formed by this process that's called outgassing. To summarize it, outgassing is just gas being released from inside the Earth into our atmosphere. It happened through volcanoes, primarily earthquakes, breaks in the Earth and stuff like that. Just like now when a volcano goes off, there's a lot of carbon dioxide that is released. Same process. It's just that back in the day, there was a lot more volcanoes and activity on the surface of Earth. So there was lots of gases being released. The gases that were released were these. The gases that came out were carbon dioxide. So again, this is a little bit redundant, right? Because it says outgassing and outgassing. So please make these notes yours. Don't write down word for word. Write down what you need. But the primary gases that came out of Earth were carbon dioxide, nitrogen, and argon. And do you notice that there's an important one in our atmosphere now that is missing from this atmosphere? Oxygen, right? You ever see Bill and Ted's Excellent Adventure? Yes. If you have. Next bit. Shortly after the earth cooled down enough to let there be liquid water, because remember I was saying that the water just kind of sizzled off, it was so hot. As soon as it got cool enough that there could be liquid water on the surface of Earth, we had living critters on our surface. Not oxygen breathers, because there was no oxygen. You're writing this down, right, Elliot? But we had living critters on Earth. Do you know of any critters that are alive that breathe one of those three gases? Not breathe, but use like either carbon dioxide, nitrogen, or argon? What kind of organisms use carbon dioxide? Plants, right? So we think the first things on Earth were photosynthesizers, similar to plants, probably like single-celled algae and stuff like that. What do you know that plants release? And that's how oxygen got here. We think, that's the theory, that oxygen got here because these things, their byproduct, right, the thing they give off is oxygen, and we think that's how it got into our atmosphere, was these plants slowly, however you want to believe it happened, those plants and photosynthesizers happened, and then as they do their thing, they release oxygen. And that's what it says here. The life that began on Earth began to photosynthesize, and when it does that, it converts carbon dioxide into oxygen. And that made it so that you and I could do our thing. If it wasn't for that, if photosynthesis didn't produce oxygen, we would not be here. There would still be no oxygen on Earth. So I'm pushing a little just because we've got till 13, and I want to make sure we get the last two bits here. But when oxygen was present, that's what allowed us to form our ozone layer, because then when thunderstorms happen, ozone would be created, and it formed the ozone layer around us. So we didn't always have an ozone layer. That only happened after we had oxygen here. And the last thing, the very last note you're going to take today, is that only about 60% of the Earth's history has there been oxygen. So for 40% of Earth being around, there was not usable oxygen for critters to utilize. And when you got that, you are officially done with your notes. Too. But on page 7, in the middle, right here, it says picture of Earth. So anytime I ask you to draw a picture, it's got to be at least 3 colors. So like a 3-color picture of Earth. Have you seen my drawing?
Yeah.
It's horrendous. If yours is like mine, that is fine, as long as you've got a 3-color picture of Earth. Do you have to draw it? Nope. If you're really scared of your own art, you can cut out like a small picture of Earth and color it there. That's fine. Whatever you want to do. But picture of Earth in the middle. And do you see there's like 4 little bubble things coming off of it? You're going to put information in each of those. In the top right one, I want 2 to 3 sentences on the formation of our atmospheres. Like how they formed, right? So atmosphere number 1 and atmosphere number 2. How they came together. Bubble down, corner right. The purpose of our atmospheres, or what they do to protect us, we went over 3 things, right? Ultraviolet rays, temperature, and then space meteors. Bottom left side, the composition of it, like what are the gases in our first atmosphere? What are the gases in our second atmosphere? Top left, can you guys not pack up yet, please? Haley. Top left-hand side, the changes that took place in our atmosphere, like the development of oxygen and how that happened, how we went from having no atmosphere after our first one left to having an atmosphere as our second one was here. So those are the 4 like bits of information you're going to put there, and then you've got 4 pictures that go around. This one is going to be a color picture that represents the changes that took place somehow. So you could show like gas coming out of the earth, like spewing out of volcanoes or something. A 3-color picture of like the formation of it, like our Earth spinning through and going through accretion and picking up gases that are collected to it. A picture of its purpose, so our atmosphere burning stuff up or blocking ultraviolet rays as like a superhero with a shield blocking rays from coming down to Earth. And then here, just a picture of the most common gases, so like a little chart or whatever you want to put there. So this video will be, if you lose track or don't know what to do, this video will be available to you, and it'll be at the very end of the video where I explain this. So you can check that out tomorrow. But your homework tonight is to go home, and everybody at your table is going to put together their own version of this, their best version. When you come in tomorrow, you guys are going to collect the best pieces from everybody's and create like the best poster for your table. Have a wonderful